Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a better blind 75 coding series. So today's problem is on word search. We have to find a word if it exists in the grid or not. So let's quickly jump into the problem statement, understand it and start solving. Last time we have solved the letter combinations of a phone number. We'll mark it check. You can find it in the list. Let's start with word search. Okay, given an m cross n grid of characters board and a string word, written true if word exists in the grid, the word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter cell may not be used more than once. Okay, so the problem statement is quite clear. For the solution, we'll come back to it. Okay, so this is a given grid ABCE, SFCS, ADEE, and we have to find if ABCCED exists or not. Of course, so when we start, let's say we started with the first letter A, it matched A. Now we want to search in four directions. Top does not exist, left does not exist, bottom does not match, and right B matches. So we move forward. Now, to check that top does not exist and left does not exist, we can simply check in the grid bounding conditions, right? If it's outside our rows and columns. For the character that does not match, we can simply check it with the if loop. Now from B, the next character we want is C. So we search for C. Top does not exist. We know how we can check it. Left, we have already visited. So somehow we have to mark that the previous node was already visited, right? So that we don't search back even if a C exists in the back, right? Bottom does not match, right is C. From this C, top does not exist, B already visited, E does not match, C matches. So this way we reaches the next C, then E and then D. Now after reaching D, at this point in time we want to know that we have actually found the complete word. So we need to keep an index, right? So that when the index value is equal to this word length, we would know that a word has been found. If at the end of this a word is not found, we'll simply return false. So what we need to do is we need few conditions to keep in mind. First, we need to take care of that we do not visit the node that cell that was already visited. Second, we have to check for the boundary conditions so that we are always inside our columns and cells, right? Third, we have to check when the index has reached the word length so that a solution has been formed. Next, we want to search in all the four directions so we can actually make a backtracking method and then call it for all the four possible directions, right? And we have solved numerous problems on backtracking by now. I think in this series we have solved roughly 5-6 problems on backtracking. So it's a pretty easy solution approach as well. Please excuse me. I'm sorry. Yeah. Okay. So with this, we can actually start and let's do the dry run with the problem solving. Okay. Let's start. So first, since the word is given as a string, let's convert it to character array, right? So we'll say convert the string to character array for easy access. Okay, so we can say char word array is equal to word dot to char array. Done, right? Now we are going to iterate through each of these cells because this word ABCED, for our case, yes, it started with the first cell, but it could have started with the next cell or the next cell or the next cell. Like in this case, we want to find C. C does not start with this one, this one, this one, this one. So we have to iterate through the entire grid, right? So we'll say iterate through each cell in the grid. Okay. Next, for int I is equal to 0, I is less than board dot length I plus plus. Next, for int j is equal to 0, j is less than board of 0 dot length j plus plus. Okay, right? Now we'll start a backtracking method. So let's create a separate method and then recursively call it again and again. So we'll call it once from here, and then from inside the method we'll recursively call it, right? So we can say we'll call it backtracking, not function but method. Okay, private boolean backtrack. What all do we need? We need the given board, so board. We need that cell, we need the specific cell, so we need the I and j, right? So we can say int I, oops, something is wrong, yeah, int I, int j, and then we need our word, so character word, since we have converted it to character array. And in the end, as mentioned earlier, we want to keep a pointer or index to keep count of the length of words that we have covered. So int index. This index will be responsible for calculating how many characters we have already covered, and once that has reached the length of the word, our word has been completely found. Okay, yeah, that's all. So let's call it from the for loop. So we can say start the backtracking from the current cell, because we have to start from each cell, right? So if, and if it returns true, right? So let's say backtrack, will pass board, next is I, j, word, and then for index will pass 0, right? Our first index was 0. If it comes out true, we can simply return that the word is found, return true, right? Word found. Or if the for loop is over and we don't find it, we can say return false, word not found. Okay, let's start with this method now. Okay, so as we go with each backtracking, we need three functionalities, right? One, the break condition, that is also the base case. Then a mechanism to call this method again and again, right? So, and also, since it's backtrack, to redo the last formation. Let's say we chose A, B, C, C, and the solution was not formed here, right? After C there was no E adjacent to this. We find the solution somewhere else. We see A, B, C, E, E, A, B, C, C, E. So we backtrack and remove all the paths that we had taken to reach this position, because it can happen, right, that after this B, a C was at this position also, sorry, after this A B was at this position also, but we took A, B, C, C, E, D path, right? So those are the three conditions for any backtrack. So we'll use our base case, and also base case would be the breaking condition for this backtrack. So when will we break this loop? Once the index has reached the word length. Check if we have found the word. Okay, if index is equal to word dot length, return true, right? Next, since we have to check for all the outside bounds condition, that is outside the grid, we'll keep a check directly for them, right? Check if the current cell is out of bounds, or it does not match the required character, or the character doesn't match. Oops, match. Okay, so we'll say if I is less than 0, or I is greater than equal to board dot length, or or j is less than 0, or j is greater than equal to board of 0 dot length. What else? Or board of I j is not equal to, oops, it's going somewhere outside, let's increase this. Board of ij, that is the cell value, is not equal to word index, right? If this so happens, we can simply say return false. Otherwise, since we do want to mark the last cell that we already covered as visited, so we'll just change the value. So we'll temporarily mark the current cell as visited. So we can say temporarily mark the current cell as visited. How do we mark that? You can simply change the value. So we can say character temp is equal to board ij, and then board ij will simply change the value to start. Oops, it has to be a character start, right? Now once we have matched C and we reach the next C, we'll not be searching back, because before C would be appointed a new value as star, right, which will change along after when we are doing the backtracking, right? So now we can say, now once we have considered this word, once C has been considered, we'll explore all the 4 directions. So we'll call the same backtrack method again, and we'll change the I and j values, and also of course the index. So we can say explore adjacent cells in all 4 directions. So we'll say boolean result is equal to backtrack. What all do we need to pass? We need to pass board, need to pass I plus 1, j word index plus 1, okay, or let's keep it together. So we have this backtrack, let's copy this, command C, right, or E, or so if any of these conditions is true, right? Now we have to check for all the 4 directions. So I plus 1 j, similarly I minus 1 j, similarly I and j plus 1, and then I and j of course minus 1, right? If in any of these direction we find the next character, this particular backtrack would return true, and then we'll move forward. Once we have a true from this one, we'll restore the last value, that is the backtrack part. So restore the original value of the current cell. So we can say board I j is equal to temp, right, and return result, whether it comes out to be true or false. Okay, I think we have called this method backtrack, and it is calling, we have the checking condition, we have the out of bounds and non match character check here, then we are exploring all the 4 directions. In the end we return the result. Okay, let's run, let's expand this. Oops, cannot be converted, line number 10. What's wrong here? We passed the word, we need to pass the word array. Let's run it again. Okay, let's submit. Great, right? So that is all from today's video, everyone. And and in the end, yes, the time complexity will be n cross m cross 4 raised to power l. N cross m is actually for the grid, and 4 raised to l is because 4 is for the direction, l is the length of the words, right? That will be the overall time complexity. So for anything else, please let me know in the comment section, and in the end, please like, share and subscribe. And guys, if you do have certain questions or doubts or anything, please feel free to comment them in the comment section. Okay. Yeah, in the end, please like, share and subscribe. Thank you.